Underlying technologies of blockchain. There are three underlying technologies in blockchain: the peer-to-peer network, cryptography, and blockchain protocol. The peer-to-peer network. First, in the initial stages, we were having a centralized server which had many nodes connected to it, and it used to have a centralized ledger. But with the peer-to-peer network, we have each node connected to each other and no central server at all, and each node is having a copy of the ledger with him. So now what happens in the centralized ledger? If there is a transaction which has happened, it will get updated out here in the centralized ledger, and whatever the server says, every node has to maintain that only, and they have to say it is the truth. But if he cheats, like this server cheats to them and changes something in ledger, they have to believe it. But in the distributed ledger, if suppose this node wants to change anything in the ledger, it will only get changed in his copy of ledger and not everybody's. So everybody will first verify if the transaction is correct or not, then only it will get updated in each of the ledger. So if there is any change in the transaction or any new transaction is added, it will get reflected in every node's ledger only after it has been approved by the majority. So in this, a majority is needed. If the majority says that yes, the transaction is correct, then only the transaction will be put in all the ledgers, or else not. Cryptography. Cryptography is also a main part of the blockchain technologies. So we'll study in this asymmetric key encryption. This asymmetric key encryption generates a pair of key for an account, namely a public key and a private key. The public key is shown to everybody as some account number, and the private key is kept personal to the person itself whose account it is, and he only can access it. So it's more of like a password. And this has a very good property that if a data is encrypted by a person's public key, it can be decrypted only by his private key, and vice versa. So I'll show you an example of how this works. So there are two friends of mine, one is Pooh and the other one is Rads. So in this asymmetric key encryption, Pooh gets a set of private key and a public key. So this is her private key and this is her public key. Here Rads also gets a private key and a public key. The private keys are marked in red and the public keys are marked in green. So now think of Pooh wants to send a text to Rads, but in between there is a whole network where it might get changed or hacked. So what to do in this case? So what does Pooh do? She writes the plain text, then encrypt it with her private key and Rad's public key. So it gets encrypted in a ciphertext, it goes through the network, and then when it reaches Rads, she unlocks it with her private key as her public key was used for encryption, and she also decrypts it with Pooh's public key as Pooh's private key was used during the encryption. So now the decrypted message is the same as the plain text which was sent by Pooh. So what happens, why are we doing this? Because if we do this, we get to know, like Rads gets to know that it was sent by Pooh because it was her private key which was used for sending the plain text. So Rads knows that it can only be sent by Pooh and not anyone else. And even Pooh cannot at a later stage tell that I didn't send it because her private key was used during encryption. Similarly, only rats can decrypt the message because it was her public key which was used for encryption. So nobody can decrypt it except her because it's rat's private key which was used to decrypt it. Blockchain protocol. In the blockchain protocol, there is something known as hashing. Hashing, a hash function, is any function that can be used to map data of arbitrary size to fixed size values. The values returned by hash function are called hash values. Properties. It is a one-way function. One-way function means that the data which has been taken, the input, will give an output which cannot be reverse engineered. So the hash, which is the output, cannot be taken and cannot be decrypted into that initial input file or data. It is a one-way function. Avalanche effect. A bit, like a very small bit of data change or a mere space can change the hash to a very different hash. No duplicacy. There is very rare chance of having a duplicate hash. It's almost impossible. Like the best hashing functions are SHA-256 and KEKAK. The SHA-256 takes any kind of input and gives output as a 256 bit or 32 byte hash. So in this 256 bit, there can be about 2 power 256 combinations, and the probability of getting a duplicate value is very low. So in this image you can see that there is an input cat.jpg in which there is a cat's picture which is first uh, made into a binary code, then it is put into the cryptographic hash function, and then it gives out the output as the hash of 32 bytes or 256 bits.